Hello, grade 10s, and this is the video for 5.6 or Unit 5, Lesson 6. Now, if there's ever a video that you really want to pay attention to and watch the whole thing of, it's this one. This is by far the toughest lesson, I would say, in this unit, and a lot of students struggle with it. So I highly recommend that you pay attention, put away distractions, tuck away your phone, or, I mean, if you're using your phone, I guess that's fine, but really try to pay attention to this and always remember that you can always come back and re-watch a video if you're struggling with the assignment, okay? So just a little recap of domain and range. We talked about domain and range in the other lessons in the first half of the unit. Now, I'm just going to do a little refresher of what the definitions are for each one. So the domain is defined as the X values of a relation, okay? Or another way is we can always consider it the left-hand side. So if we're talking about like a table of values or an arrow diagram, it's always typically the one on the left, that's the domain, okay? Today, we're going to be dealing with graphs. And so the domain, if we're talking about X values, well, X is the horizontal axis, right? You know, when we have a graph or a grid, a Cartesian plane, it's always YX like that. So we're talking about the values on that line right there when we're talking about domain, okay? Range is the opposite. So range is defined as, the Y values of a relation, or the right-hand side. Okay, but if we're talking about graphs, it would be the vertical axis. So the one going up and down, how high, how low. Okay. So also in, another definition, function. For something to be a function, just a little recap here, there has to be no repetition in the domain. Now, when I corrected your assignments for the Unit 5 halfway assignment, a lot of you said that it wasn't a function if there is repetition anywhere. It's actually okay for there to be repetition in the range on the right-hand side. We're allowed to have repetitions over there. It's in the domain that we don't want repetition. So if we see something repeating in the domain, then it is not a function, okay? All right, we're going to be using some symbols in our answers today, and we're going to be using these 4 symbols here. So just a little recap. The symbol that looks like this, okay, that symbol means less than. So for example, we would have something like 4 is less than 5, okay? This one here, when it has the little line added underneath, that's less than. It's the same direction or equal to. All right, so that little line just adds in, we add in that equal to part. Okay, when you have the symbol going that direction, it's the opposite, greater than. And then of course, same thing when we add a little line here, that would read greater than or equal to. Okay, so we're going to be using those symbols in all of our answers today. All right, let's put our thinking caps on. Because for each one of these graphs here, we have to determine the domain and range. Okay, then we have to determine if it is a function. The way that we determine that, the way we determine if a graph is a function or not is something called the vertical line test. And I will explain that when we get to it. All right, so first question here. Determine the domain and range of this graph A. Okay, so we know domain means, I'm actually going to change to red. We know that domain, so I'm going to identify it with a D, and then I'm going to open up my squiggly bracket. That's how we identify domain in the other lesson as well. Okay, same thing. But here it's a graph, and this graph is fluid, meaning it starts here and it travels and then travels and then travels and then it stops. Okay, so to figure out what the domain is, we have to figure out what x values does this graph touch. Okay, so what I do is I say, okay, well, look at where we started. We started right here, right? What value of x is that? Well, it's right here, this little tick right here, which is -1, -2, -3, -4, -5, -6. So we know we start at -6. Then what I say is it travels and travels and travels and travels and then ends right there. What value is that for x? That is the value 1, 2, 3, 4, 5, 6. So we travel from -6 to 6, and it touches every x value in between, right? Because it's a solid straight line. So it's -6 and then -5, then -4, then -3, then works its way all the way to +6. So the way we write this, instead of going -6, -5, -4, -3, all the way up to 6, that's really annoying. What we can do is use those symbols I talked about. So we know it starts at -6, okay, and it ends at 6. We're going to leave a little bit of space in the middle. And then because we're talking about x, I'm going to put an x in the middle, and then we choose our symbols. And when we choose the symbols, I'm talking about these 4 symbols here, those kind of Pac-Man symbols. If you put the lower number here and the higher number here, if you put it in numerical order from smallest to greatest, you actually never have to think about what symbol to use. You will always go in that direction. So I'll repeat that. If you put the smaller number here, which you always should, and if you put the larger number here, we will always use that direction of symbol, because we all imagine that's an alligator. The alligator will always want to eat the bigger number. If an alligator is faced with a really scrawny deer and a huge fat deer, it's going to eat the big fat deer. Okay, so this, we want the mouths, if these two are mouths, we want them to be eating towards the 6, the bigger number, the fatter number. Okay, but we're not done, because if we look up here, at the -6, that's a solid blue circle. And at the +6, that's also a solid blue circle. That means those, at that point, it is also equal to -6 and is also equal to 6. So in grade 9, you would have learned about number lines. So say I had a number line with a 4 in the middle and an open circle, and then I had some coloring to the right. In this case, we would say x is greater than 4, because I colored in the numbers that are higher than 4, but I wouldn't put a line there because it's an open circle, okay? And then when it's a colored circle, that's when we include the line. There's a little recap from grade 9 there. Okay, so we're done domain for this graph, which is the x values from left to right. Now we have to do the same thing, but with range, okay? I'm just going to clean this up here and start over. So for range, that's my y-axis. Okay, so I'm looking at this axis right here. I want to know, where does the graph start and where does the graph end? But now we're working how high and how low does it go? So when we were doing the x-axis, we were working from left to right because it was horizontal. Now we're working vertically, and the question is, how high does the graph go and how low does the graph go? So I typically start with how low. That's where I begin. So if we look for the lowest point on the graph, it's right there. What value of y is that? Well, that's the value of y is 0. Okay, then we look for the highest point on the graph, which is right there, and that's the value of 1, 2, 3, 4, 5, 6. So there's my 2 numbers. I ordered them again from lowest on the left to highest on the right. We're talking about range, which is y, so that goes in the middle. And remember, if you order your numbers like this, lowest on the left, highest on the right, you always will eat in this direction. And because they're solid blue circles at those points, we're also going to say equal to. So that's like saying y, the y values for this graph start at 0 and work our way up to 6. Okay, the graph spans every y value from 0 to 6. And we're done. Okay, next one here. Again, we're dealing with domain. That's what we always start with, which is the horizontal axis. So I'm looking for how far left and how far right does this graph go. So my furthest left point is right there, which is at the value of -1, -2, 3, 4, 5, 6, -7. So that's my value on the left. And then how far to the right does it go? Well, that's the furthest right value. That's at 1, 2, 3, 4, 5. And then I put X in the middle. Now, you always eat in this direction if you put your numbers in that order from smallest to biggest. But be careful here because at the -7 over here, it's a solid blue line. But then over here, it's an open circle. So that means we will not put that line there. And take that away because it's not equal to 5. So that means that for this graph, we have every X value being used between -7 and 5, but not beyond that because the graph stops. All right, range. Now I'm doing how high, how low. So I usually start with, that's a really ugly squiggle. I usually start with the most left value because that will be, sorry, not most left. I'm in range now. I will start with the lowest value because, right, we're working vertically now. How high, how low, up and down. So the lowest value of my graph is this point right here. That's how low as we get, and that is at the value of -1, -2, -3 on the y-axis. So -3. And then my highest graph, the highest my graph goes is this guy here, which if we look over to the left, that is at the y value of +1. So this graph starts as low as -3 and works our way up to 1 and touches every value in between, but not beyond. All right, I ordered my numbers from lowest to greatest, so there we go. And I'm going to have a line at the -3, but I'm not going to have a line at the 1 because, again, it's an open circle there. And we're done. I just realized I forgot to mention if these were functions or not. So to determine if they're a function, we do what's called the vertical line test. So what we do is we draw a line or a few lines. It's really ugly. We draw a few lines vertically through the image and we see, do my lines ever cross the graph twice? This line crossed once, 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 once. So that means there's no repeats. No value of X is ever being used twice. Okay, so it passed the vertical line test, so we'll say yes, it is a function. Here, same thing, you're going to draw a few vertical lines. Does it ever chop the line twice? No, it only touches once, 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 so it passes the vertical line test, so it's a function. Okay, I'm just going to erase those lines. They're a little bit annoying. Okay, so yes, that's a function as well. All right, over here, domain. So domain is the x-axis, how far left, how far right. Well, looky here. If I said what's the furthest left point of the graph, well, that's as far left as it goes, but that's also as far right as it goes, right? It doesn't actually span anything. It is in one spot. It is on -1, -2, -3, -5. So we just say for the domain, x is equal to -5. It is exactly at -5 and doesn't touch any other x value. So we would use the equal sign here. Range is how high, how low. So this is different because we have a lowest point right here, which is at the point of -2 for the y-axis. And then it has a highest point, which is at 1, 2, 3, 4, 5, 6. Okay, y is in the middle, and we're going to have just the symbols like that with no lines because both circles at either end are open. All right, now vertical line test, is it a function? If I drew a vertical line through the graph, it touches in multiple spots. It touches every single spot I go to, right? So that means that this is a non-function. And if that confused you, just think about this. If I asked you to plot the points of this graph, starting with the highest point, that would be the point -5, 6. Then if I went down 1, this point right here would be -5, 5. Then if I went down another one, it'd be -5, 4, and so on. So we can see that -5, whoops, -5 is being repeated. And the -5 is the domain. Right? So that's why it's a non-function. We're having repetition in the domain. All right. We're going to go a little bit quicker here. I took my time explaining those first few. Okay, here we have a circle. Fun. All right, domain. Values or the horizontal axis. I'm looking for how far left and how far right. So my furthest left point is this guy here, which is -4. So my graph kind of begins at -4 and then it travels all the way over here and ends at +4. So this circle is kind of living between the values of -4 to 4. We always eat in that direction, and because this blue circle passes right directly through -4 and 4, we know it would be equal to them as well. Range, now we're looking at the vertical axis, so how high, how low. I always start with my low point, so that's my low point right there, which is at a value of -4. Then I look at my high point, that is at a value of 4. So we're saying that this circle lives between the values of -4 and 4 on the y-axis. There you go. Same thing. We put lines underneath because we can see it passes directly through that point. It would be equal to that. Now, vertical line test. If I go like this, with that one line, it touched in 2 spots. So that means that this is a non-function. All right. Next one. Okay, so this is a little bit different because we have arrows. And arrows mean it goes on forever. So for domain, again, we're looking at the x-axis, the horizontal axis, how far left or where does it begin and how far right does it go? So this is where it begins. What x value is that? It's right in the middle, so that's 0, okay? And then once it starts traveling, it travels technically forever. We don't know where it ends. All we know is that it starts at 0 and gets bigger from there, right? It starts at 0. Then it spans 1 and then 2 and then 3 and then 4. So it's always just getting bigger than 0, but we don't know where it ends. So all we do for domain is say that my x values are greater than 0 or perhaps equal to 0 because we can see it passes right through the 0. And that's all we write for this one because we don't know the end value. Range is how high, how low. Now this one's a little bit weird, so please listen. Do we know how low this graph goes? No, we do not. Because of this arrow right here, and we can kind of see that this graph is in like a downward motion, it would kind of keep going on forever and ever and ever and ever and ever and gets lower and lower and lower and lower and lower. Same thing here, it's kind of in an upward motion, so it would go up and up and up and up and up, and we'd actually never know how high it goes, and we never know how low it goes. So for y, we actually don't know anything specific. So when we don't know anything specific, this is what we write. We write y is an element. This is the mathematical symbol for element. It's like a curved E of real numbers. And to represent real numbers, it's like an R with a double stem. Now what that means is we actually don't know anything about y, but we're assuming that this graph goes forever and ever and ever, meaning that it would technically touch every single y value known to man, right? It goes up forever and down forever. It'll touch every single y value. So this just means y is an element of all real numbers. It will touch every number. Okay? And is it a function? No, because it touches in 2 spots. Non-function. All right. This one here, domain, how far to the left and how far to the right. I know that it starts right here at a value of x is 0. Whoops, I'm going to stop. I'm going to erase that for a second. I know it starts at 0, but I do not know where it ends. So we have another one of those cases where we know the beginning point, but we do not know the end point. So what I'm going to say here is that x is just greater than 0. So we kind of start at 0 and then we span the higher numbers. Our numbers get bigger because they go 1, 2, 3, 4 as we go to the right. And we do not need to put a line there, right? Because it's an open circle. Range is how high, how low. Okay, well, it's just a flat line. All we know is that it touches at y is 4. It does not go above 4. It does not go below 4. So we just say y is equal to 4. Is this a function? Yep, only touches in 1 spot. Okay, 3 more. I'm going to boogie here. This one's similar to the one we just saw, but we do have an endpoint. So for range, for domain. How far to the left? Well, that's at a value of -3. How far to the right? That's at a value of x is 5. So x lives between those two values. We always put our Pac-Mans in that direction. If you put lower number on the left, I'm going to have an open circle on the left and a closed circle on the right. Range, how high, how low? We don't know. All we know is that it's always at -1. Doesn't get higher than -1, doesn't get lower than -1. Is it a function? Sure is, passes the vertical line test. Okay, here. How far left, how far right from my domain? My furthest left point is right there, which is -4. And then my furthest right point, whoops, that was a terrible line, is right there, which is 2. I have closed circles at each extremity, so I have the lines included in my Pac-Man symbols. Range is how high, how low. There's my highest point, there's my lowest point. So my lowest point is -2 on the y-axis, and my highest point is 4 on the y-axis. So my y values for the graph live in between -2 and 4. It does not go beyond that. I included the lines in the Pac-Man. Okay, this guy here, whoops, function. Yes, it is a function because it passes the vertical line test. All right, last one, domain. How far left, how far right? So look for the furthest leftist point, which is right there, and that's at a value of -3 for x. And then my furthest right point is at a value of 4. And I'm not including lines underneath my Pac-Mans because they're open circles. This point right here throws kids off a bit because they think that, oh, right there, x is 0, that they have to include a 0 in the answer, but you don't. That point doesn't matter for domain. For domain, all I want to know is how far left and how far right. So I only use those two values. Okay. All right. Range. That's how high, how low. So where's my lowest point? There's my lowest point. So I will end up using this point eventually. My lowest point is right there, which is at a y value of 0. And then my highest point, it's a tie between those two, and both of them are at the value of 5. And you'll see that I included the line here at the 0 value because it's a solid circle, but I did not include it with the 5 because those are open circles. Is this a function? Yes, it is. It only touches at one spot every time. Okay, so there you go. I know that can be a little bit tricky. The assignment today for this is a worksheet plus a few questions from the textbook. I imagine you will have some problems, so always remember you can feel free to email me or message me and remind if you need help. Okay, good luck.